take a deeper look into CAM. So we stay in English. So we want to turn our attention to computer-aided manufacturing and want to hear what are the market trends, what are the trends that are shaping this field, how can companies take advantage of them. And therefore we have a great speaker who is called Robert Molz, who is CAM application engineer at Dassault Systems. And it's a pleasure to have you here. Big applause, ladies and gentlemen. I didn't know that you're two of you. Ah, yeah, remember that.
All right. Hope you can hear me back there. Seems pretty loud. So my name's Ishan.
I'm Robert. Hello.
And we're from Dassault Systèmes, the company that doesn't make planes, but probably any plane you've flown in was engineered using some of our software. And we're here to talk to you about the trends in the CAM market that we see as a company. So this is a little table of content of what we're going to go over. We'll talk a little bit about Dassault. Robert will take over, talk about automation in CAM, AI in CAM, and how the CAM market is moving closer and closer to the real world. Especially what our customers need is a turnkey solution that not only generates and runs the machine, but orchestrates a shop floor and orchestrates an enterprise. So we're Dassault Systèmes, and we're really a solution provider of virtual solutions for real life. And we have 25,000 people working all over the world. We have 184 offices around the world. We have about 42 million end users, 11 million students, and we serve all industries across various domains. And we bring to these industries the 3D Experience platform, our game-changing platform that allows you to work seamlessly across all engineering disciplines and manufacturing. The 3D Experience platform it brings together all of Dassault Systèmes' capabilities, such as CATIA, SolidWorks, Enovia, all on a single platform based on a data model with a unified database. So everyone works on the same piece of information. The compass, as we like to call it, has our applications built around it based on what they do, whether it is social and collaborative applications, 3D modeling, simulation, or things to do with information intelligence, data science. So in the 3D Experience platform, we have Delmia. So Delmia is a brand within Dassault Systèmes. And we bring solutions that address the real-world challenges of the manufacturing industry. And we like to say we collaborate, model, optimize, and execute. And we also serve 12 different industries. So we serve companies that make hygiene products right up to companies that make aircraft. So we have a really diverse set of customers, which means Dassault Systèmes has a diverse range of knowledge and know-how that we have gathered over the years. Speaking of over the years, this is a little timeline to show you how long we've been around. So starting with CAD/CAM in 1981 in CATIA, Dassault Systèmes has built a really powerful legacy in machining. We launched Delmia V6 in 2008, which was really the start of a new era, and which later in the year 2012 became Delmia Machining on the 3D Experience platform. So at this point, this is when Delmia CATIA V5 Machining, which is very well known in the market, became Delmia Machining. And through various acquisitions like Aprizo, Quintic, and Ortems, we were able to really address the end-to-end capabilities of a manufacturing enterprise, from planning, operations, and supply chain optimization. And recently, we even acquired Diota, which is now Delmia Augmented Experience, which brings in augmented reality capabilities into Delmia's portfolio. So with that, I'd just like to play a little video that shows you that talks about our legacy in the CAD/CAM space. So that's the legacy of Dassault System, and that's why we can talk about trends in the CAM market, because we've been around for more than 40 years in this space. We have 5,200 customers. We serve various industries, aerospace, automotive, and we have a best-in-class CAD/CAM solution on the 3D Experience platform. We integrate out of the box with CATIA and SolidWorks, and we have a best-in-class manufacturing solution in the Delmia portfolio. So with that, I'll hand it over to Robert.
Thank you, Ishan. And yeah, the first point on the agenda is CAM in automated manufacturing. And why did I choose this topic? Well, trends are driven mostly by demand. And when we look at the market today, the demands that we are seeing primarily are pressure to reduce time to market, pressure to reduce cost, and pressure to be more flexible, to be able to respond to changes in demand. And when we ask ourselves, what is the solutions to those demands? And when we speak to people here and when we look around here, what's being shown and offered by the different manufacturers, we see that, in fact, automation is for many the first answer to that question. And when we take, for example, a cell like this, where we have a CNC machine, we have a robot that's loading and unloading parts, doing assembly operations, doing deburring tasks, we have to ask ourselves, how can we implement this? And this is where we face challenges, because here we are talking about experts from different domains that have to work together, which in many cases are not necessarily all placed in the same location. So already there's the first hurdle. And in this example, what we had in this project, we had a project lead in Switzerland, we had a robot programmer in France, a CAM programmer in Germany, and they all needed to work together to make this one cell operational and productive. And Dassault offers an answer to this question by offering our services or our software on cloud. So this enables us, or the customers more specifically, to collaborate across domain borders and also across country borders. And when we look at a project like this, it comes in different phases, of course. First, we have to plan it, and we program, then we validate, and then we actually implement. And what I want to focus on today is the programming step. So here we face two challenges. First of all, we have to have efficient and reliable machining process. And then we have the robots we have to take care of. We have to be able to program the deburring operations that the robot has to do to finish the part in some way. When we first look at the machining process, of course, we have the roughing to take care of to make it as efficient and reliable as possible. And therefore, we have advanced 5-axis technology that allows us to use shorter tools, allows us to detect undercuts and remove the material even from hard to reach areas. But roughing is not everything. Most of the time actually is spent in finishing, where we have to machine the fine details and where we have to make sure that we are able to limit our toolpaths exactly to those areas where we find the rest material, not to waste any time machining air. And this we support, of course, with advanced rework strategies. So much for the machining. The next question is then how to program the robot. And there are many robot solutions out there, but they're mainly focused on maybe assembling or welding tasks. They're not really adapted to creating toolpaths. And the answer to that is really to integrate the robot in the CAM system, because that's where we have all the technology that allows us to generate those toolpaths that are needed to really create smooth surfaces or actually do deburring tasks. And this is what Delmia machining supports. So Dassault offers an extensive robot library. These robots can be used and then programmed by the same people that would also program the CNC machine without any additional need for training and using the same software, same interface. And to expand a little bit on the topic of programming robots, for us, we see two scenarios. So first scenario is where we have already maybe a robot that's doing unloading, loading tasks, and which in the meantime, while the machine runs, is idle. So what would be ideal would be to reduce the machining cycle time and use the robot to do exactly things like I already mentioned, deburring or similar tasks. So this is where we would have then additional spindles, stationary spindles, which the robot will move the part to do those tasks. The second case would be we have a robot which has a spindle attached to it. And the scenario here for us would be maybe large parts with lower requirements in terms of precision, for which a machine tool would be maybe too cost intensive or too long a lead time, and robot would be perfectly capable of fulfilling that task while even being more flexible. So when we put this together, what are the advantages that we see? Okay, first of all, by planning and programming all within the virtual domain, we are able to decrease time to market. We are able to see the problems that may arise. We are able to react. By automating, of course, we are able to make production more flexible. And by automating, of course, we gain productivity and therefore reduce cost. And all of this together is, of course, a real benefit to customers. The hot topic today is AI. And the interesting thing about AI today is how do people implement that new technology? And there is lots of different approaches that you can observe in the market. And everybody finds their own answer. And here are some of the answers Dassault is giving today. So for example, AI is strong in pattern recognition. So what we can offer today is to leverage that capability in reuse programming. So for example, in a scenario where you have left-hand and right-hand parts, we can use that pattern recognition to apply the toolpath that's been programmed for a left-hand part to a right-hand part without any manual intervention necessary and without doing things like mirroring or anything. You really have a new program that's unique to that part and can be edited. So we can see that here in the video. So when the AI recognizes the surfaces, it's able to adapt the machining operations from the previously programmed part to the new part. And that's the last step. Now there's anything that's left to do is recalculate, and you'll have your new program. Next topic I want to talk about is large language models. Everybody knows them, ChatGPT, etc. And this is the second strength of AI today, is language recognition. And within the 3D Experience software, we have also a chatbot that allows the users to ask questions. And the nice thing about it, the chatbot will reference all the knowledge that is stored on the 3D Experience platform. So it could be internal documents And chatbot is able to synthesize this information and give back the fitting answer to the end user, and it will also reference to the sources it used to generate this answer. So this is then where we can maybe jump into the documentation or some internal document that gives us the answer and then apply it. So in this case, it was a easy question how to replace a machine in Delmia machining. The system led us to the correct page in the documentation. We found our answer, and then we're able to do what we have to do. So, with the programming done, it's not the job is not finished. So actually, the programming is only half the job done. After the programming is, we have to actually produce a part and get it out the door just in time. And this is where we meet the real world. So this is where we have to take into account machine capacity, maintenance, but also unpredicted events. And what it basically comes down to is we need to be able to take this in account during planning and also execution, and then be able to adapt. And there's a reference from the sporting world which says everyone has a plan until they get punched in the mouth. And that's exactly what's happening in real life. And you need to have, and this is where the demand then comes for a system that helps you to adapt to those situations that arise which you have not previously planned. And in engineering, we need to integrate with CAD, CAM, PLM, process planning, and quality to be really efficient. But that's only half the story. We also need to integrate into the systems landscape to be able to communicate with other CAD software, with our scheduling tools, with our ERP, and with our manufacturing execution system. And Dassault provides for that via the enterprise integration framework, which provides openness to integrate with all those systems. And therefore, we're then able to integrate with those planning tools that help us to actually run the production smooth and efficient even when things go wrong. But we also get clients who ask us for a whole solution, end-to-end solution. So, and in this scenario, we don't want to integrate with other systems or existing systems. We want to be able to offer an end-to-end solution to our customers where we connect our 3D experience with our other tools, Delmia Aprisio for manufacturing execution, and Autumns for manufacturing planning to create what's a complete end-to-end solution. That over to my colleague.
Thanks, Robert. So you just heard the three important points. Yeah, at the end, what Dassault is doing is really breaking those silos between various parts of a manufacturing enterprise, right? From the CAM programmer right down to the shop floor execution. That's what Dassault is trying to do. We're trying to break those silos, trying to build that real digital continuity end to end. So we're talking about CAM trends, but you don't have to just believe us. We have some customers and partners who would like to share that with you. So we have a bunch of lectures that are coming up in the upcoming days with our partners and customers. So we have on day 2, which is the second day of EMO, we have a lecture by our partner Technia, but also ISCAR, which is a very big partner of ours for machining. On day 3, we have a presentation by Wintool and our partner Bechtle with Sandvik Coromant, and there is a big surprise announcement there that we would like to do. And we will also show you more in detail our digital continuity from CAD into CAM. So 3D experience coming into Delmi machining doesn't mean you have to be a SolidWorks or CATIA user. You can come from other CAD systems, and your story will continue seamlessly into Delmi machining. On day 4, we have interesting presentations with our partners Makino and Vericut. So Makino, we will show you Makino machines within 3D Experience. We are capable of simulating not just the toolpath, but the entire machine kinematics to really give you a virtual twin of the machine that you really are going to execute on the shop floor. We'll show you Makino in our solution. Of course, Vericut. And we have an interesting presentation by Coriolis, which is one of our partners that specializes in AFP, composite fiber laying, automated fiber laying. And we will wrap up the day 5 with some more insights into AI and automation in Delmi machining. And we will also touch upon the topic of robotics, which Robert was talking about. We're one of the few solutions that's able to really address that trend in the CAM market, which is to really address manufacturing work cells and not just a CNC machine and a robot. Thank you.
The end. Let me step here. You're blocking the ways. Thank you, 2 of you. Just one final question to you. Why are you doing these lectures? That would be important. So you prepared, and I like this really much because this is a way to introduce the people into that. But what is the purpose? What is the target you want to achieve with the lectures?
Well, we really want to talk. We really wanted to express our point of view as a company. The CAM space is a really old domain. People have been around for a long time. People have different points of view. And we really wanted to show you what we have seen in the last 40 years happening in the CAM space. And we thought we would like to share it with a larger audience and show you also a direction in which we're taking our solution, which is keeping up with those trends.
Yeah. And you will have real examples over there. It's not like only lectures, right? If I understand, it's like real use cases, right?
Yeah. Yeah. You will see full end-to-end use cases with all of those, all of our partners, whether it is Sandvik and Niskar for cutting tools, or Makino for the machine, or Vericut for isochord simulation. Yeah.
Awesome. So I forgot to introduce you, but I will not forget to say goodbye. Thank you so much. That was Isham and Robert. Thank you very much for your presentation. Big applause, ladies and gentlemen.
Thank you so much.
Thank you very much.